This is Sarah Junick with Drilling Contractor. Today I'm at the 2019 OTC in Houston. I'm with Austin Johnson. He's lead development engineer with AF Global. Austin, thanks for being with us today.
Thank you.
Can you tell us about the non-rotating technology that makes the active control device different from conventional RCDs?
And one of the challenges with deep water managed pressure drilling equipment is that much of it was designed for low specification land drilling operations. And an example of how equipment was designed for onshore is found in the RCD. The RCD uses a passive sealing element which is attached to a bearing assembly, and the sealing element blocks the flow of fluids up the annulus, while the bearing assembly allows the element to rotate with the drill pipe to reduce wear. Onshore, the RCD body housing is located directly below the rig floor, and it's relatively easy for the rig crew to access it for service. But this is not the case offshore. There are other complications as well that arose from scaling up the RCD technology. One is that the increased diameters increases the seal wear. It has driven additional requirements for precision engineering and manufacturing above and beyond land RCDs. And it's required expert technicians to perform the service and maintenance of the bearing assemblies. Couple that with the fact that the riser deployed RCD is a little bit more difficult to access for the rig in deep water. It also slows the run and retrieval operation of the bearing assembly. There really hasn't been any change to the fundamental technology over the years. There's still no way to adjust the seal quality and no way to determine the remaining seal life while the seal is installed. So the ACD takes a completely different approach to containing wellbore pressure. The ACD uses field-proven components such as a dual seal sleeve element assembly, a dual spherical annular packer assembly, and all of that is controlled by an active direct hydraulic control system. The ACD does not have any rotating parts, and instead the drill pipe rotates within a non-rotating seal sleeve element assembly. And active mud lubricates the sealing surfaces of the elements.
What are some of the key benefits deepwater operators can gain from using ACD?
Well, the ACD enables active sealing condition monitoring. So we can monitor the state of the seal elements while it's installed and in operation. One of the major benefits of the ACD over the older RCD technology is that the ACD completely eliminates the bearing assembly and all of the costs associated with it. Instead, the ACD uses the actively controlled seal sleeve elements, which do not rotate with the drill pipe. And the ACD uniquely enables active seal condition monitoring so that we can monitor the state of the seal while it's in operation subsea. In addition to this, we're able to adjust the closing pressure acting on the seal sleeve elements over the life of the seal so that we can monitor and control seal life as the seal wears.
And what results did you see in your recent deepwater deployment with ACD?
In the field, the first ACD system was delivered as part of a larger MPD package to Noble Drilling. In addition to the ACD, we delivered a complete MPD control system which functions as a central hub for all third-party MPD systems, MWD systems, as well as our own topside and subsea. It collects all the data and transmits it into the rig's drilling control system and onto the operator. Now, in terms of the performance of the ACD, we've just wrapped up the first 14-inch MPD section this last month. And going forward, we'll continue with 2 additional MPD sections until we TD the well. Now, after we finish the well, we're going to have a lessons learned session with the contractor and the operator, and we're going to then take those lessons back to our technology center and our full-scale test rig and continue to advance the ACD.
Well, thanks again, Austin, for being with us today.
Absolutely. Thank you, Sarah.
And thank you for watching drillingcontractor.org.